Hello class, in this video we're going to cover 6.8, which is arguments and Euler diagrams. So I would suggest that you watch the videos before the question set. If you click on a homework assignment and the video and question set pop-up doesn't appear, it just goes straight into the assignment. You can still get to the videos and the list of questions by clicking on the menu button at the top left of the homework assignment. So if you see a little menu button up there in the top left, when you open that, it'll open up a window like right on top of this one, and it'll have all your videos over here and then all your questions over there, okay? If there are no videos, then you'll just see all the questions on the left-hand side, okay? So I just want to make that a point to make you guys aware of that, just because some of those videos are super important to put together the information so that you can understand it. In here, in these videos that I'm creating, I'm just going to be going through the problems with the information that's shared in those videos, okay? So I think what I did in oh, never mind. That's for the review. Okay, so for problems 1 through 3, it has the same direction, so I just kind of grouped them together. It says select the statement that best matches the Euler diagram below. And so for number 1, this is the Euler diagram, and here are the statements. So it says some Q are W. Well, here's Q and here's W. That one is true. There are some Q that are W. That's not false, okay? But it says which one is the best match. So let's keep going. Now here it says no W are Q. Well, that's false because that's inside the Q, okay? All Q are W. That's not true because you've got some Qs outside of W. And then finally, all W are Q. And that is true because all of the set of Ws are inside Q. And so all W are Q is the best option. Now, number 2 says, has this image, and then the suggestions are all W are Q. That's wrong because W's over here and Q's are over here. Some Q are W. Again, that's incorrect because they're not connected. All Q are W. No, that would mean Q is inside W. And then no W are Q. This is the true statement. For the third one, it has this image, and it says some Q are W. It's this piece right here. No W are Q. That's wrong because there's some W's inside Q. All Q are W. No, we have some Q's that are not inside W. And all W are Q. No, because we have some W's that are not inside Q. So the best option here would be some Q are W. Now for the next 3, or actually 4 problems, they also have the same directions. So the directions are write a conclusion to make the following arguments joyful. All joyful people are rich. And the answer is, therefore, some queens are rich. Since the queens are joyful and all joyful people are rich, then it concludes that the queens are rich, okay? And not all queens, some queens, because only some are joyful, right? Those queens that are not joyful, we don't know if they're rich or not. Number 5, all actors are content. Some content people are rich. Answer, it is not possible to write a valid conclusion. This is because it is possible that the content people who are rich may not be actors at all, but content people of other professions, okay? So yes, I know that all the actors are content, but I don't know what the content group consists of. It only says some content people are rich. I don't know who all the content people are, so I don't know who the people are that are rich, okay? All I know is that some of them might be actors, right? Because all the actors are content, but all the other content people, who are they? Okay, what are their professions? We don't know, so we cannot make any conclusion here. Now, number 6 says, if it floods, the roads will be slick. If the roads are slick, there will be more accidents. If there are more accidents, the police will be overwhelmed. The police were overwhelmed. Here, it is not possible to write a valid conclusion. This is because it is possible that the police were overwhelmed due to other reasons than accidents due to slick roads due to floods. So we don't know why the police were overwhelmed. If they told us police were overwhelmed by more accidents, then even then we wouldn't know, because we don't know what all of the accidents are caused by. We only know that slick roads can cause more accidents. I'm sure there are other situations that cause more accidents that we just don't have all of that information. Number 7 says, if it rains, the roads will be slippery. If the roads are slippery, then there will be more accidents. If there are more accidents, then the fire department will be overwhelmed. It rained. Well, this one follows that if it rains, right, then the roads were slippery. If the roads were slippery, then there were more accidents with an S, and therefore the fire department will be overwhelmed. So this one, it's like all 3 pieces of information. And I think you have like options. Like one of the options is the roads are slippery. Second option is there's more accidents. Third options is the fire department is overwhelmed. The fourth option is all of the above, which is what I have here. And then the last option is that it's not possible to write a valid conclusion. So for this one, it would be all of the above. For these, it would be not possible. And for this one, it was not possible. Okay, now let's keep going. So for number 8, it says, same instructions. It's going to continue to keep going for all of these. So if there is a water main break, the roads will be slippery. If the roads are slippery, there will be more accidents. If there are more accidents, the fire department will be overwhelmed. There were more accidents. So all I know is that there were more accidents, and we know from this statement here that if there's more accidents, the fire department will be overwhelmed. So that's the only conclusion that I can make, is therefore the fire department will be overwhelmed. We cannot assume why there were more accidents. So I cannot say because there were more accidents, it's because the roads were slippery, and the roads were slippery because the water main broke. Remember, these are one-sided, what are they called? Implications. So you're saying if you have this, then you have that. It does not work in the reverse. You're not saying that if the roads are slippery, then it must mean that the water main broke, because the road could be slippery for any kind of reason. Okay, there are many other possible reasons of why the roads are slippery. Okay, so you cannot go in the reverse. You can only go forward. So this means this, this means this, this means this. So all I know is that there were more accidents. So I started with this on the left, and I know this fact on the right. I cannot go any further than that. So for number 9, it says no structure that has a door is completely secure. No building is completely secure. Fort Knox is a building. The answer is, if Fort Knox is a building and I know that no building is completely secure, then I know that the Fort Knox is not completely secure. Don't know whether or not it has doors, okay? So I can't say that. I mean, you would think a building would have doors, but I'm going based off of just the information that's been given to me. Number 10, supply the missing first premise that will make the following argument valid. Some mathematicians are poor spellers. Therefore, some people who take math classes are poor spellers. Now, this one's a little weird because you do use a little bit of logic in this one, whereas this one, you're not allowed to like completely say that this building didn't have any doors in it. I mean, I guess there could be a building that exists that doesn't have a door, but that just doesn't make sense to me. But either way, even if we assume that the building did have a door, it says no structure that has a door is completely secure. So even if I assume that this building had doors, even this top statement is saying that it wouldn't be secure. Okay, so this conclusion still follows for both of those statements. Whereas here, I am making a little bit of an inference because I know that if I'm a mathematician, I'm probably going to have to take math classes, right? And we know that all mathematicians have to take classes. Or no, that's the bit of information that I'm missing. So if you tell me, right, because that's what the question asks. I'm sorry if I'm confusing anyone. I got twisted around a little bit. Start off again. The direction said, supply the missing first premise that will make the following argument true. So really, I should have put a blank. I should have had a blank line in the middle because you need to have one statement first, then this statement second, and then this conclusion. And they're essentially asking us what statement needs to be made up here in order to make this statement, along with that first statement, draw this conclusion. Okay. And the only statement that could work is that all mathematicians take math classes. Because if all mathematicians take math classes and some mathematicians are poor spellers, then that means some of the people who take the math classes are poor spellers. Okay. Because all the mathematicians are going to be in the math class. And some of those guys are poor spellers. So some of those people in the class are poor spellers. So this is the bit of information that was missing to make this argument true. Statement 1, statement 2 above the line, and then the conclusion below the line. Now let's try this again. This one, number 11, is a little bit different. This one says, use Euler diagrams to determine whether the following argument is valid or invalid. All English professors are good readers. J.R.R. Tolkien is one of the English professors. Therefore, J.R.R. Tolkien is one of the good readers. So essentially what you have here is, it says all English professors are good readers. So that basically means you have this. These are the good readers. Okay. So all English professors are good readers, which means all the English professors are going to exist inside the good readers bubble. And then J.R.R. Tolkien is one of the English professors, means J.R.R. Tolkien will also be inside the English professors. So therefore, J.R.R. Tolkien is one of the good readers makes sense because not only is it inside the English group or set, it's also inside the good reading set, good reader set. Now, number 12 says, use the Euler diagrams to determine whether the following argument is valid or invalid. And so over here, I forgot to mention that that statement would have been valid. I had it written down and I said that it makes sense, but I never answered the actual question whether it was valid or invalid. Okay, now number 12. It says, use Euler diagrams to determine whether the following argument is valid or invalid. So all evergreens are trees. The blue spruce is one of the trees. Therefore, the blue spruce is one of the evergreens. So what I've drawn here is the table. So we have one bubble that represents all the trees. And it says that all evergreens are trees. So it's in here. And then it says the blue spruce is one of the trees. The issue is I don't know whether the blue spruce goes in this part of the tree circle or if the blue spruce goes this side of the tree circle. Based on the information that they gave me, I cannot know where to place the blue spruce item. Okay, so the comment left here says, We don't know if blue spruce is a non-evergreen tree or an evergreen tree from this argument anyway. A blue spruce is an evergreen, but based on the information given in the argument, concluding that the blue spruce is an evergreen was an invalid conclusion to make solely based on the argument / facts provided. The word "and" should not be in there. Okay, so yes, I literally Googled because I don't know a lot about trees, but I did go Google whether or not the blue spruce was an evergreen, and it actually is. And so this statement is true, but I would have had to have known that in order to make that conclusion. Just based on this person's argument, they are not making a valid conclusion based on just the facts that they've given me, okay? It said it was one of the trees, not one of the evergreen trees. So I don't know, and I can't make that conclusion. So what do you answer here? You answer that it is invalid. There's just not enough information given to make that claim. Now, number 13. Number 13 says some people like cats, some people like dogs. The conclusion is, therefore, some people who like cats like dogs. And there's an issue here because I drew all the 4 different possible Euler diagrams. So the possible Euler diagrams you can have is one that is disjoint, which means they don't touch each other. One where one is inside the other. This is called the proper subset. One where they are, this is also a proper subset, but the reverse. So see here, the small group is D and the large group, the small group is dogs, the large group is cats. And this is the reverse. The small group is cats and the large group is dog. And then here's where they just overlap a little bit. Okay, so they are jointed, but just a little bit. I think this one's called the common sets. Okay, so those are the 3 different possibilities, or 4 different possibilities. And there's actually another one, and that one is if the set of cats and dogs is exactly the same. Okay, so there's really 5 options. Now, here it says some people like cats, some people like dogs. So I just know that there's people that like cats and people that like dogs, and there could be other people out here that don't like cats or dogs, right? That's the same situation for all of these, okay? I am not given enough information to know whether the people that like cats are not the same people as that like dogs. They are the exact same people. Some of them might be the exact same people, or just the people that like dogs are the ones that like cats, but not vice versa. Or just the people that like cats like dogs, but not vice versa, okay? I do not have enough information to figure out which one, okay? So this argument would only be correct if the second diagram were correct, okay? So some people who like cats like dogs, that would be this situation where some of the people who like cats like dogs. Here, all of the people who like cats like dogs. Here, not all of the people who like cats like dogs, only some of the people who like cats like dogs. So it actually would be these 2. And then here it's all again. Since we don't know which to choose based on the information given, the argument is invalid. You should be able to make a concise conclusion, but I cannot, so it's invalid. Number 14, same direction. So first statement is all painters are artists. Second statement, some painters are unemployed. Therefore, some artists are unemployed. Now what I've done is it says all painters are artists. So I made artist the big circle. And since all painters are artists, all of the painter circle would be inside the A circle. Then it said some painters are unemployed. So that means I need to get to some of these painters because some of those painters need to be in the unemployed category. Well, in order to do that, I'm actually going to have to get some of the artist spot as well, okay? Because this one is inside this one. And so then if you notice, not only do I have some of the painters inside the unemployed circle, but I also have some of the artists inside the unemployed circle. And these painters are artists. So even just this little sliver being inside you by itself makes this a valid statement. But I also might have some other kinds of artists, like maybe some oil paint, that's painting. Maybe I have some sculptures, I don't even know what the word is, sculpturist. I don't know. I'm a math person. I'm not an English person. Not fantastic with my words, but there could be other types of artists that are in here, okay? Artists that make sculptures, artists that draw, they don't paint, artists that do a lot of digital content, you know what I mean? There's all kinds of artists, and some of those might be still employed. Now, number 15 says, consider the following statements. All new Camrys are excellent items. Some new Camrys are a liability. Let C equal the set of new Camrys. Let E be the set of excellent items. Let L be the set of liability items. Draw the Euler diagram for the two statements. So this first statement that says all new Camrys are excellent items, that means that all the Camrys would be inside of the excellent items, okay? Then some new Camrys are a liability. That would mean that C and L are going to overlap. They won't be completely inside one another because only some Camrys are a liability. And so then we have this situation here. So I've got the E with the Camrys all inside, and then with the L overlapping with some of those Camrys. Consequently, it also overlaps with some of the, excellent items. But more importantly, it does overlap with this. So the answer is going to be this Euler diagram. Now, number 16 is very much the same. It says, consider the following statements. All new Corollas are excellent items. Some excellent items are a liability. C is the set of new Corollas, E is the set of excellent items, and L is the set of liability items. Now, all new Corollas are excellent items means the same thing, that here's your Corollas and they're inside the excellent items, okay? And so I've drawn that twice over here. Then the second statement says that some excellent items are a liability. So this means that E and L should overlap. Now, that means it could be one of two different cases. It could be where just the E and the L overlap, or it could be where all of these overlap, okay? It could be, it didn't tell me whether the Corollas were a liability or not. And because it didn't tell me whether they were or weren't, I can't assume one versus the other. And so you basically have two options here. Now here it says, use Euler diagrams to determine whether the following arguments are valid or invalid. So 17, all fish are cold-blooded creatures. Some cold-blooded creatures are reptiles. Therefore, some fish are reptiles. And so what I've done is the all fish are cold-blooded means that if M is the fish, N is the cold-blooded creatures, and P is the rectangles, this statement up here is telling me that N is inside M, okay? And so then I did draw a circle with the M on the inside, okay? And then the second statement says that some cold-blooded creatures are reptiles. So some of the cold-blooded creatures are reptiles, but just like the previous problem, it didn't tell me whether or not some of the fish were reptiles or not, okay? So it could be this situation, or it could have been possibly this situation. But you cannot assume that the fish are in that the fish are part of the reptiles, because otherwise it would have specifically stated that. And because it didn't specifically state it, they're saying that this cannot be the possibility, okay? So it is invalid. Notice that the fish do not touch the reptiles section. Now, here is 18. All fish are cold-blooded creatures. Some fish are reptiles. Therefore, some cold-blooded fish are reptiles. Now, same thing here. Oh, that's what it is with this one, okay? So in the previous one, you were just asked to find, you were just given 2 sentences, right? You were given 2 sentences, and you were asked to find possible Euler diagrams for them. And so these were the 2 possible Euler diagrams. Now over here, with the information that we're given with these 2 statements, these are the 2 possible Euler diagrams. The issue is that in order for this statement to be valid, it has to be valid in both of these possibilities, okay? And the problem is that yes, it would be valid. It would be valid here, right? Because if I have them double overlapping like that, then yeah, some fish would be reptiles. So it is true with this possibility. But when you look at the other just as equivalent possibility, this one, the fish cannot be part of the reptiles. So we don't know which one it is, okay? So you can't choose this one over this one. So what you have to do instead is look at both. If both of them say that it's totally valid to make this conclusion, then it is a valid conclusion. But if one of them is invalid, or even if both of them were invalid, then it makes the whole conclusion invalid. So even though it was valid for this situation, it was not valid for this situation. And so therefore it just made the comment invalid altogether, okay? So the argument is, or not the argument, the conclusion isn't that it's invalid because we can't choose this. It's because you have valid and invalid, which makes it invalid overall. Okay, so even though this one is invalid, or even though this one is valid, this one is invalid. They would both have to be valid in order to say it's valid, period. Okay, so number 18, I also have two different pictures for this, because it says all fish are cold-blooded creatures, which means that the M should be inside the N, and I've drawn that twice, just like I did up here. Okay, and then once I had that, we have what is it? Some fish are reptiles. Some fish are reptiles. That means some of M needs to be in P. Now, it really wouldn't matter if it was like this or if it was the same section. Like if this circle was all up against the end of this circle. And so what is the difference between these? This one is saying that some of the cold-blooded fish, cold-blooded creatures may not be fish, but may still be reptiles. And here, this is saying only the fish that are also cold-blooded creatures can be reptiles, okay? So they're a little slightly different from each other, but regardless of which one you look at, the conclusion, some cold-blooded creatures are reptiles, is true, because N is the cold-blooded creatures. So not only do you have the fish that are cold-blooded, you have some other creatures that are cold-blooded, and both of those kinds of creatures are in the reptile group. Whereas here, just the fish that are cold-blooded are reptiles, and no other cold-blooded creatures are reptiles. But regardless, both of them are saying that there are some cold-blooded creatures that are reptiles. And so here, this conclusion is valid. And it didn't matter which picture you looked at. Okay, last two problems. So this one is same thing, use the Euler diagram to determine if each argument is valid or invalid. So number 19 says, no rats are dogs. All nice animals are dogs. Therefore, no rats are nice animals. So rats and dogs should not be connected, okay? Because it says no rats are dogs. So immediately I know that rats and dogs should not be connected. Since nice animals, it says all nice animals are dogs. So that means all the nice animals should be inside the dogs. So there's my nice animals inside the dog section, and the dog and the rats should not be connected. So the conclusion is that no rats are nice animals, and they're not connected at all. The nice animals is over here. None of them are overlapping with the rats, so it is a valid conclusion. Number 20, some dancers are healthy. If you are frugal, then you are healthy. Therefore, some dancers are frugal. So let's look at this one. Some dancers are healthy means that the dancer set and the healthy set should be connected or overlapped. Okay. Then the next statement, if you are frugal, then you are healthy. This means the frugal should be inside the healthy. Because if I'm frugal, I am automatically healthy, okay? And so I've drawn that in both of these scenarios. Again, here the dancers and the healthy people are connected and the frugal is inside the healthy, but it just so happens that some of the frugal got looped in. Whereas here, dancers are there, healthy and frugal are here, and here none of the frugals got looped in. We don't have enough information to decide whether it's this one or this one, okay? Now, the statement of some dancers are frugal, here that would be valid. But here that would be invalid. And we already learned that if we have two Euler diagrams that fit the description, they would all need to be valid in order for you to say that the conclusion is valid. If even just one of them is invalid, the conclusion itself is invalid. So that's what we'd say here. We still don't have enough information to choose one over the other. The diagram on the right shows the argument can be invalid, which makes the argument invalid, okay? So invalid is the answer there. Okay, that is the end of section 6.8. And so in the next video will be the test 2 review. So I will see you guys in the next video.